So let's take a look at some trigonometric applications in 2 dimensions. So some of the ways or techniques we're going to use to get through this, obviously SOHCAHTOA that we know. We look for using the sine law. We want to try to use the cosine law. And we're always aware that there are, our general geometric rules. There's always Pythagorean theorem, sum of the angles in a triangle and complementary angles in a triangle and so on. So we can always use geometry. Don't forget, we can always use geometry to help us get through some of these questions. So we know SOHCAHTOA, we're pretty comfortable with that. Here's an example. How deep is the water in the boat? Here's my primary angle theta. This is the opposite, and this is the hypotenuse. So I would be, what uses opposite and hypotenuse? That would be sine. So I know I could write sine 39 is opposite d over hypotenuse 30. And then I could go from there and solve for d. Sometimes we see some navigational questions, and it's important to orient ourselves properly. So we have this compass here. This is north, obviously east, south, and west. That would be our directions. And we use these kinds of questions when we look at air travel or when we look at travel on water. So here's an example. Imagine 2 boats leave Coburg at the same time. You have a red boat and a blue boat heading off in certain directions. And if the boat travels at 12 kilometers per hour, and they travel for 1.5 hours, then you know that distance is going to be 18 kilometers. You just multiply those two things together, and that gives you your 18 kilometers. So that's the distance traveled. So imagine here's kind of a diagram here. Here's us in Coburg. There's one ship in that direction, another ship in this direction. The question is, how far apart are they? What we're going to try to find is that D after an hour and a half. So we kind of want to orient this on a compass so we can kind of build our angles. And we want to try to find that D. And there's that 18. It's just 12 kilometers per hour times 1.5. So just to kind of reconstruct this here a little bit, this is the D I'm trying to find. Sorry, too fast. This is the D here I'm trying to find here. I know this is 18. I know this is 18. So is there a way I can figure out this primary angle theta? If there is, I can use the cosine law. And of course we know there is, because I know in half a circle I have 180 degrees. So I know I can do 180, take away the 50, take away the 55, and whatever that leaves me with, that would be my theta, my primary angle here, theta. And then I have a contained angle, so that's theta. I know that's 18, I know that's 18. I can use the cosine law to solve that one. Quick example of the sine law. We know how to build this. I'm going to go x on top. X divided by sine 42 is 11 divided by sine 50. Right? I know how to solve this. That gives me my answer. Quick cosine law question. This looks a little more complicated than how we need to write it. So okay, I'm just going to solve a squared. It's just the 2 sides squared, 21 and 32. So right here, 21 and 32 minus 2, 21, 32, cos 40. That's that contained angle. So really, we jump in right there, typically. And then we usually just skip down to the answer there. So that's the cosine law. Now, really what we're going to start looking at are multiple triangle questions. So the question here would be find H. But if I look at this triangle on the right-hand side, I don't really have enough information yet. So I then have to look over at this triangle and say, do I have some information here given to me that would then allow me to fill in this triangle that would then allow me to get H. So this is one of those multi-step triangle questions that we're going to start looking at. So we take a look here, and again, we sort of just work our way through this to say, well, I'm going to think about some geometry here. This is an isosceles triangle because of that and that. If that's 60 there, oh, it's red, you can't see it. If that's 60 there, then that's going to be 60, excuse me, in there. If I know that's 85 and that's 60 to there, then I know I can find that angle in there. And then once I have that angle, I'll draw it up here. Once I have that angle in there, that's 10, I can then find H. So it's almost like we start over here and we just work our way back across this way. Here's kind of a question. I have Cape Canaveral here in Florida, and we have Houston over here. And you want to figure out how high a satellite is. You know the distance between these 2 spots. They can determine the distance there, and you can determine the distance there. You can measure the angles, those are pretty easy. the question is, how high is this satellite? Okay, what is h? Can we find h? In this case, we took a look at it initially and we say, well, okay, here's our right triangle, h, theta. I don't have this little distance down here. I have the entire distance. So I may need to use this entire distance first. So let me just redraw this here. Make it a little bit easier to see. Here we go. So I have this entire distance. If I want to deal with this right triangle over here, it'd be nice if I could find, this side here, because then I'd have a right triangle. So how can I find that? Well, I would need this distance down here if I could find it. Can I look at 60, 47? I can figure out that angle in the big triangle because I know the sum of the angles in a triangle is 180. So 180 take away 60 take away 47 would give me theta up here for the big angle. And then if I knew that angle, let's see now, I have a side and an angle. I'm trying to find the side and I have an angle. Okay, I could then kick into the sine law. I would write the sine law, this with this, and then this with this, and that would allow me to find the question mark. And then once I have that question mark distance, I know with this triangle here, I can solve it just with SOHCAHTOA, right? This is my primary angle theta, that's my opposite, and that's my hypotenuse. So I would just use sine at the very end there to figure out h. That would work. Finding a height too. So imagine a balloon, you release it, it floats, and then it keeps floating, and you want to try to find the distance from the first spot to the second spot. This is a non-right triangle, so we say, is there something we can do? And remember, I want to point this out, if you have two triangles, you can always consider them as one big triangle. So if that's 60 and that's 25, I know that's, okay, this is a little funny, it's going to be 85 degrees. Yeah, the scale's off here, but don't worry about that. I can figure out that entire angle as 85 degrees. So if that's my primary angle theta, this is basically my base or my adjacent, I can figure out the entire height, the big height. Well then, once I have the big height, I can figure out the little height here, h1, because I have the little triangle down here. So I have primary angle 25, 300, opposite adjacent, tangent would give me that. So tan would give me the little one. Once I have the big height, so the big height is there to there, and once I have the little height there to there, I could then figure out h2 just by subtraction. Okay, try 254.